Okay, here are the remaining two examples from section 3.2. There are two additional proofs here. We have SR congruent to TR. We have WR congruent to XR. And I have SX congruent to WT. That's all given. Let's mark that on the diagram. SR congruent to TR. WR congruent to XR, and then SX, I'm going to do this to mark the congruence, congruent to WT. There's a lot going on here, so let's mark the triangles we want. I need triangle STW. STW. That's this one right here. That's the green one. And I need that one congruent to TSX. TSX, which is the orange one. So if you look closely, right, I do think we have one part of those triangles. I have this segment right here. I have SX congruent to WT. So I definitely have a side. I don't think I can call SR a side because the side of the green one actually ends at W. And I can't call this marking a side because the orange triangle ends at X. So if I look closely though at these two congruent markers and this one, I think I should see overlap. So hopefully you realize we can subtract this segment and this segment to get SW. And I can subtract TR minus XR to get TX. So that would be if congruent segments are subtracted from congruent segments, then the differences are congruent. That gets me this piece congruent to this piece, and now I have another side. So that's either going to be side, 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 or maybe side, angle, side, right? I need one more piece. You really need to look closely at the diagram. When I traced over the green and the orange, you should have seen something right here. Isn't this side ST part of both the green and the orange? So I can say it's congruent to itself using that reflexive property. We talked about that in the last section. I just write that it's congruent to itself and I write reflexive. Now that's my third side. Now I have side, side, side for the triangles. STW congruent to TSX by side, side, side. So it's kind of a good idea sometimes to keep track of the parts you have, so that when you get to the end you know which congruence you have. Let's look at the last example. All right, this is a long one. We have JH congruent to FG. Let's mark that. JH and FG, those are those long segments. K is a midpoint, and I'm going to write it out this way. K is a midpoint of, it must be JH, and M is a midpoint of FG. All right, that's that piece right there. I should have said what they were midpoints of. Now hopefully you are seeing, when I write it this way, you are seeing two midpoints, and you are remembering that probably means I need to use multiplication or division. We'll come back to that. HKF is congruent to FMH. Let's find these. HKF, that's this angle, congruent to FMH, this angle right here. I have KJG congruent to MGJ. KJG, that's this angle, congruent to MGJ, that's this one. Really important to mark your diagrams carefully. JGH congruent to FJG. JGH, that's this guy, congruent to FJG. FJG, this one. All right, that's a lot of given. I'm also going to take a good look at the triangles I want because there's a lot in this picture. I need triangle FJK. FJK, that's this green one, congruent to HGM, which is this orange one. So look closely. I don't think all that given, and I don't think we have a single piece of information yet. You might argue that we have something going on here, but I don't think I actually have the whole angle yet. So hopefully you're realizing that we can get this whole angle in the green one congruent to this whole angle in the orange one, because I've got congruent angles next to each other, so I can add. So I can say angle FJK is congruent to angle HGM, because if congruent angles are added to congruent angles, then the sums are congruent. So now I do have an angle, so I'm going to keep track of that. I have an angle. Well, I know up here I said that I had two midpoints, and I know I can use multiplication or division. So these are midpoints, and if I look at these segments, aren't these the bigs? So I have the whole congruent to the whole, and I have midpoints. So I think if I have the bigs, I can divide to get either one of these small segments congruent to either one of these small segments. I clearly want this green one and this orange one. So I can get those two pieces congruent using division. JK is half of this top segment, and it's got to be congruent to MG, which is half of this bottom segment. If segments congruent, then like divisions are congruent. Okay? All right. So now I also have a side. So this is either going to be side angle side, or it's going to be angle side angle. Well, what in the given have we not used? So look through the given, and hopefully you realize that very first angle, this guy right here, FKH, this one, and FMH, we didn't use these right here. I'm going to mark it with 3 markers to make it more obvious. How the heck are those going to help me get something inside the triangle? I hope you're looking right here. We have a relationship here, right? Don't we have supplementary angles, and don't we have supplementary angles here? Remember, that's a 3-step process. So first I have to say JKH is a straight angle. And down here I'd have to say FMG is a straight angle. That's assumed. Then I'm going to say my two supplementary angles here. Up here, they're this green one, JKF, is supplementary to FKH. And down here, I have what? HMG. This guy is supplementary to FMH. We've done this before. If angles form a straight angle, or if they add up to 180, then they are supplementary, right? But now I've got these two congruent. I've got HKF, which is this one, congruent to FMH, which is this one. These two are congruent. So therefore, the other two, JKF, is congruent to HMG. If angles sup to congruent angles, then they are congruent. All right, so I use the straight angles here and the straight angles here. Supplementary, supplementary, which now gets me this angle congruent to this one. That's another angle, and look at where it's at. I have an angle, a side, and an angle. So it's definitely including this side. In the green triangle, this angle that I got by supplements, this angle that I got by adding, right, those border this side that I got by division. So I have angle, side, angle. Triangle FJK congruent to triangle HGM by angle, side, angle. And I think that's the longest one we've done.